So we're doing a quiz this Friday. And one thing that's going to show up quite a few times, it's going to be something like this. Yeah, you guessed it. You're going to have some equation in this form, x dy plus some number e equals 0. And you're going to be asked, what kind of conic section is this? And you're going to have to draw it, graph it and stuff. And I've been very explicit with what I'm looking for each type of thing. We'll talk about it as we go on. But since this is the case, it's going to be imperative that you know how to complete the square. That is, if you can't complete the square, you're not going to do so hot on this quiz, right? So, but I do want to talk about this real quick. So, for instance, here's a for instance of something that will show up on the quiz. Okay, there's one. First off, the very first question, I give you something like this, and I tell you, this defines a conic section. Identify the type of conic section, and then in parentheses, I have circle, ellipse, parabola, or hyperbola, and graph it, labeling the vertices, if applicable, and asymptotes, if applicable, and all axis intersections. What I mean by vertices, if applicable, is this, that a circle, I spell circle right, C-I-R-C-L-E, that just looks weird over here from the right-hand side. A circle, we're going to say, has no vertices. It just has a center. It has a center and radius. And so if you have a circle that you're going to draw, right, wherever it happens to be, really we just need the center labeled. And I'm not going to ask you to label the radius, although, I mean, it's a nice practice to do, like to go ahead and label the radius, like radius equals 5 or whatever, something like that. But that's not going to be really necessary. However, it might be in your best interest if you do have a circle that, let's say the radius, or let's say the center is here at 3. So the center is at 3, 0, and the radius is, say, 2. It might be in your best interest to go, well, wait a second. If the radius is 2, then going over 1, 2 would bring me here to 5. Going over 2, 1 would bring me here to 1. And so, yeah, we've labeled our axis, our intercepts and stuff like that. But notice, those aren't vertices. Those aren't necessary that, like, for instance, that you say, oh, this one's up at 2 and this one's down at -2. If it's a circle, we don't really think of the circle as having vertices. So it's not necessary to label those 4 points, but it might help you to put those 4 points on there, depending on the context of the problem. But in the context of this problem, when it says to label the vertices, we're not talking about this right here. A circle technically has no vertices. So I'm just trying to avoid possible misunderstandings that have to do with stupid technicalities. Okay, but so that's the deal with the circle. We're not, so just so we know. So now, so we're clear, an ellipse has 4 vertices, right? And they occur at those extreme values, right? So let's say I'm going to off-center this ellipse a little bit. We'll say we have this ellipse right here. The highest point is one of the vertices. The lowest point is one of the vertices. The farthest right is one of the vertices, and the farthest left is one of the vertices. No, I don't know if we explicitly stated that, but let's just get this out right now. So an ellipse has 4 vertices. It also has foci, which we don't care about. We're not going to worry about. There's a nifty formula you could look up to find them. It's not really that important right now. Okay, a hyperbola. A hyperbola has two vertices. And depending on the type of hyperbola, and I'm even going to shift this guy so that we don't think about it as just one static thing. On a shifted hyperbola, right? And shifted over, it looks like, and then up, it has those two vertices like this. And those 2 points right there, those are those innermost, or if it's going the opposite way, it's the highest and lowest point. But here in this case, it's the innermost points. Those are the vertices. Hyperbola also has asymptotes. And so it also has those. And in the prompt for the question, I'll just read it again. It says, graph it, labeling the vertices if applicable. So if it's a circle, you won't be labeling vertices. It says asymptotes if applicable. So if the thing is a hyperbola, you will need to label the asymptotes. If the thing is an ellipse, you won't need to label the asymptotes because an ellipse doesn't have asymptotes. So I just want to get all this out right now. It's just stupid technicality stuff. And all axis intersections. So in this case, with this ellipse that I've drawn, two of those vertices happen to be the x-intercepts. But the y-intercepts here are not marked, or they aren't vertices, and so we would have to find them and label them. Ditto right here. This guy, it just so happens that he doesn't go through the y-axis because of the way that I drew it, but he does go through the x-axis, and so we would have to find those two intercepts right there. If I gave you a really wicked one of these, it might look something like this, where it actually has both, maybe, where it goes through, let's say that's a vertex and that's a vertex. You found the vertices, but now we would also have to find 1, 2, 3, 4 intercepts to go along with it. Oh, and the asymptotes. Can't forget the asymptotes. We would want to label those as well. So that is one of the things you're going to have. You're going to be given something like this. You're going to be told identify what type. So I would like to see, don't just draw it. Like I want it written somewhere on the page. Circle, ellipse, hyperbola, or this is what we're doing, right? Parabola has one vertex. And I think we know all about that bad boy. We've talked about parabolas at length. Watch your head, buddy. This guy been banging his head on stuff. So much like his father. Okay, so that's what's going on there. And so given something in that form, you would need to, well, I think you know what to do, but we're almost always going to have to complete the square to figure out what's going on. And I want to make this point right here. So I'm going to get rid of this stuff. Am I ready to get rid of this stuff on the board?
Yeah, sure.
Okay. So that's what question 1 is gonna be like right there. Now, question 2, I'm gonna give you a bunch of equations, and it's very much like your homework from not the one that you just turned in, but the one before that, the one in 10.6, problems 1 through 9. From chapter 10, section 6, problems 1 through 9. It said, tell which conic is defined by each equation. And then you have a bunch of equations and you simply identify the conic section. I'm going to, that's what problem 2 is. It says the following equations define conic sections. Identify the type of conic section, circle, ellipse, parabola, or hyperbola, for each. Then I put in parentheses, yes, that's it, but be careful. What do I mean by that? Well, this is what I want to talk about right now. So now, obviously, if you have something like this. Let's just get this up here and we'll say, how about minus 3 squared equals, let's do this. Let's do it this way. All right. What type of conic section is that?
Sorry, I'm so.
Okay.
Right. That's a circle.
That is a circle. How do you know? Because it has the form of a circle, Justin. I mean, like, so what I mean though is what I look for when I see this is like, well, first, the thing that jumps out at me is there's no number out in front of here, right? There's no number out in front of there. The only thing is that there's a number over here, right? And so like that's immediately what my brain does. But now what if I did this? What type of conic section is that?
Wouldn't that also? Oh wait. Yeah, wouldn't that also be a circle?
It would also be a circle. It's tricky, right? Because you think, well, oh, wait a minute. Like when I see this, I think ellipse because I go, oh, there's stuff out in front. So it's an ellipse. Then I stop and go, well, hold on. If it's an ellipse, then if I get this side over to 1 and I'm just going to do this real quick. Let's just watch. I would need a 1 over here, which means I would need to divide this entire thing by 5. And so I go 5 and 5. And now I'm just saying, oh, it's an ellipse. Let's just keep going. I guess that would be 5/3 and then plus and a y minus 3 squared, 5/3 square root squared, I guess, square root squared. Oh, wait a second. It's been stretched the same distance here and there. Oh, wait a minute. And this is kind of what goes through my head, right? Is I think, well, if I took that down, I'd have some, oh, but I'd have the same thing in the denominator. Oh, wait a minute. Okay, then. Another way of writing this would be then, why don't we just divide everybody through by 3? X minus 2 squared plus y minus 3 squared would be 5/3. Now I'd say, oh, that's just a circle. And that's the case whenever that's the same number right there. Or it could have written it as divided by 3 and divided by 3. Whenever those numbers are the same, you can rewrite it so that you get those guys by themselves. You get this guy over there, which can be written like this, which means that it's a circle centered at 2, 3 with radius root 5/3 right there. And so it's a little tricky, right? Because at least for me, when I look at that, I go, oh, that's got to be an ellipse. But wait a second, if it's the same number, then we can rearrange and stuff like that. Okay, so that's that. Now, okay. Another question. This, but let's change that to that. Now, what is that bad boy? What type of conic section is that?
It's an ellipse.
That is an ellipse, right? And I could see that because the different numbers So if I wanted to, I could go and, like I did before, divide both sides by 5. But I can see right away that after doing all that, I'll end up with a different number down here than I would have down here. We have the x's squared, the y squared. We have a plus in between. So yes, that's an ellipse. Okay. And if I had changed this, if I'd made either one of these negative, what would this guy be right here? You hear him?
Would that be a hyperbola?
That is a hyperbola. When one of them is negative, it's a hyperbola. And so the same thing's true if I had written it like this, a plus here and a minus there. Or if I had rearranged this equation somehow, right? It's another thing we got to kind of keep in mind is I might not give it to you like this. I might have taken one of these over to the other side and maybe brought this over. But when by the time we rearrange it, I could see, okay, you have something squared, you have something squared. One of them's negative, one of them's positive. Yeah, that's a hyperbola right there. When you have the opposite signs, then that's a hyperbola. Okay. Okay. Now another type of this type of question is this. So I want to do this. 2x squared plus 3y squared minus 4x plus 12y. Let's go plus 20 equals 0. What type of thing is this?
Is that a hyperbola?
Nope. Now, at this point, the correct answer to this question is I don't know. And the reason why we don't, I'm going to illustrate with this example. So, given something like this, and you ask me, Justin, what kind of conic section is this? I'm going to say, well, first off, this is not the standard form for any conic section. In order to get it into a way that I could figure out what type it is, I have to complete the square. And so now, we'll go back to there in a second. So let's just start by completing the square. I'm going to gather my x's together like that. I'm going to gather my y's together right here. I'm going to leave myself some room over here with the other stuff. There's plus 20 equals 0. So all I've done is regrouped stuff. Now let's see. I have a 2 in front of the x squared, so why don't I factor him out? Give myself a bunch of room here. And do the same thing with y. And without actually finding the plus or minus squared thing, you finish this up. Tell me what goes on the outside of this parentheses, outside of these parentheses, and tell me what goes on the inside here.
The 3 goes on the outside.
And then what's left on the inside?
Y squared plus 4y.
Y. Okay. Now let's complete the square on the x. I go plus what and minus what?
Plus 1 squared minus 1 squared.
There we go. Plus 1 squared minus 1 squared. And what about this guy?
Plus 2 squared minus 2 squared.
Plus 2 squared minus 2 squared. Okay. Now, this thing is a perfect square, and so I'm going to rewrite him as, it looks like x, and then that's a minus, so I go minus 1 comes in here, and then I square it. I subtract off and I'm going to go ahead and do the squaring here. 1 squared, well, it happens to be 1, so there we go. Now you're okay, buddy. You're all right. You just had a fall. No big deal. All right, you do this one. Tell me what I need to write there.
Let's see. Y plus 2 squared.
Yeah, y plus 2, quantity squared, and then what?
Minus 2 squared. Or minus.
Minus, yeah, minus.
Squared, yeah.
We can keep it as minus 2 squared or whatever. Okay, so now I'm gonna distribute in my constants so that I could drop parentheses. So my 2 comes in to give me a 2. X minus 1 squared minus 2. And then I have, what do I have here? You do this one.
3 times y plus 2 squared minus 12.
Minus 12, there we go. And I'm dropping parentheses. And so now I have plus 20 equals 0. Okay. So let's consolidate all of our constants. I have a minus 2 and a minus 12 for a total of minus 14. Now I have a plus 20 right there. So plus 20. 20 minus 14 is what?
Six.
Yeah, so we should have a positive 6 left over. I'm going to write all of this now and write this out to make sure. And I would like for you to double check me that I've done everything right up until here. And that should be a plus 6. Can you just double check this line? Make sure that I got that right.
Looks right to me.
Right. Okay. I think it looks good. So almost there, right? I have this, and right now this is shaping up to look like an ellipse. And I could see that from the beginning if I imagine what's going to happen, right? Like looking at this thing that I was given at the very beginning, I could imagine, okay, I have a 2x squared and some x's, and so I'll end up completing the square, but that 2 is going to have to come there with that guy. I have a 3y squared and a 12y, and so I'll do some stuff, but that 3 is going to have to show up right here. Furthermore, I could see that since that's a positive 2 and that's a positive 3, I'll end up with a positive 2 and a positive 3. So I automatically know that ultimately, after completing the square, I'm going to end up with a plus 2 something here, plus 3 something here. And so thinking back to the first examples that we were doing, I'm thinking, oh, that's got to be an ellipse because you have 2 different numbers right here. But here's the crux of the issue, is that what about this guy? So when I go to get this into the standard form, let's see what happens. I get 2x minus 1 squared plus 3y plus 2 squared equals -6. Uh-oh. That's impossible. You can't have that. There's no possible way. There's no real numbers, x and y. I can plug into this equation to make that true. No matter what I plug in for x, I'll square it and get a positive number. No matter what I plug in for y, I'll square it and get a positive number. And so I have a positive plus a positive equals a negative. No, you don't. That does not happen. That's a contradiction. Those are 2 arrows hitting each other. That's what you mean. That's fancy, or it's actually a lazy way of writing contradiction. Like that doesn't happen, like not going to happen. And so for the answer to this, what type of conic section would be, it's not a conic section. This is not a conic section. But we did not know that from the beginning, right? And this is the point I'm trying to make is you might look at this and go, oh, okay, a 2 and a 3. And so you'll end up with a 2 out here and a 3 out here. It's a plus and a plus, so it has to be an ellipse. No, it might be the case that after you do all of your stuff that you end up with a negative number on the right-hand side. And if that's the case, you do not have a conic section at all. Now, this could have gone down differently, though. It might have been the case that, let's just say one of these was negative. And let's just say that the 3 was negative, and we did, and it would be slightly different. But let's say that in the end, we ended up with this and that, and you go, oh, negative number, you can't have that. Well, yeah, you can, because you have a minus here. If you end up with a negative over here, it is possible because, well, I could just multiply through by -1, making this positive, making this positive, making that negative, and we could see, oh, that's a hyperbola because you have a plus and a minus. And yes, we will have to divide by 6 and blah, 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 blah. But I could tell that would be a hyperbola. Now, what I'd like to do real quick, so did that make sense about the difference between an ellipse not existing and the hyperbola existing when it's minus?
Yeah.
Okay, so I want to go back to this point right here. And let's say instead of 20, and this is what I was saying, right? Like we can't tell just off the top of our heads, just by looking at it, whether or not this thing's going to come out to be a conic section or not. So like, for instance, if this had been, say, 10 at the beginning, we would have done the same thing. We would have brought all of our stuff over here. We would have completed the square. The only difference is that each one of these guys would have been plus 10, plus 10, plus 10, plus 10, all the way down. And then we would have gotten to this point after completing the squares and redistributing. We would say -2 minus 12 is a -14 plus 10 gives me a total of -4. Right there. And then I'd say, okay, we got that. Now 2x minus 1 squared plus 3y plus 2 squared equals +4. And what type of conic section is that? Okay.
That's an ellipse, isn't it?
That's a what?
Is that an ellipse?
That is an ellipse. Yeah. And I can imagine if I took, it's not quite in the standard form, but I could put it that way by dividing by 4. So that'll be a 1. The 4 will be in the denominator, and then we'll have 2 different things. And so, yeah, one will be stretched a certain amount, one will be stretched a different amount. And so, yeah, that is an ellipse. So the takeaway point here is if you're given something in this form, you don't know whether or not it's going to work out to give you some kind of crazy contradiction or not. It may or it may not. We don't know. We have to actually go through the work, unless you could do all this stuff in your head, which I wouldn't recommend, especially, yeah, no, that's not, you can't, at least I can't just look at those and go, oh yeah, you'll end up with a -14. Like, no, it's much easier to just do the work and then go, yep, okay, we're good, or no, we're not. So, okay. So that's that. That's problem number 2. It will be, is what that's going to be. Again, you have 7 equations, and I ask you to simply identify the type of conic section. All right. Problem 3, I'm going to give you the graph of a conic section and tell you to write the formula for it in standard form. And I'm erasing this stuff. I didn't bother to ask because I'm just mean like that. So let's just be clear here what I mean by standard form of an equation. So we didn't talk about what standard form for a parabola is. So we have parabolas, circles, ellipses, and hyperbolas. We'll say the standard form for a parabola is either y equals a x minus h squared plus k, or it could be the other way around. It could be x equals a y minus h squared plus k. Right? Because it's possible that your parabola, like we said, we talked about this in class. It could be that you have some general equation like this. Let's go 2y squared minus 3x plus 4y plus 5 equals 0. So it's very similar to the thing that we just saw on the board. The only difference is it doesn't have a squared term. And what we could do is say, well, hold up. Wait a second. There's no x squared term. That's what I meant to say. There's no x squared term. Well, if that's the case, you can get x all by itself. All of these other guys, the problem is we couldn't isolate one of the variables completely. And so they have these special forms that we want for these. But in the case of a parabola, whether it's x is the thing being squared or it's y being the thing that's being squared, you actually can get one of these variables by itself. And so like in this case, I would rewrite this guy as this right here. Right? Get the x all by itself. And then I guess, yeah, to turn it into that form, I would have to actually get the x all by itself. So that would be 2/3 y squared plus 4/3 y plus 5/3. Then I would complete the square to get it into that form right there. We're going to call that the standard form, at least for this quiz. We're going to call that the standard form of a parabola. And that's just something to note, right? And that's one that you can identify right off the bat with there. It's like, wait a second, hold up. I see a y squared. Yeah, I don't see an x squared. And there is an x there. So I could get that thing all by itself. Therefore, it has to be a parabola. It just happens to be one that's sideways, but whatever. Okay. So can I get rid of this stuff right here?
Yep.
Okay. All right, a circle x minus h squared plus y minus k quantity squared equals r squared. That would be the standard form of a circle. And like we saw before, right? Like if it happened to be the case that I had something like this, like a 3 here and a 3 here, we were able to take this thing, rewrite it by dividing everybody by 3 to get it into that form right there. So this right here, as written, is not the standard form of a circle. We would have to take it and go, wait a second. And then you think, all right, that's the standard form. And I say, no, it's not. The standard form has to have something squared. You don't have something squared. So we have to do that stupid little trick where we say, okay, fine, I will take the square root and rewrite it like that. And so that would be a circle in standard form right there. All right, can I get rid of this?
Yes.
All right. So an ellipse, very similar. You have x minus h squared over a squared, excuse me, plus y minus k squared over b squared equals 1. We've seen why this is so nice, why this is even a thing, because it makes it really easy to see what this thing is, right? Like I can see, oh, it must go through the, or rather, the ellipse itself must be stretched up to a distance of plus a minus a. The y must be stretched up to plus b minus b, and then it's been shifted over to h and up to k. And so, but that's the thing, right? Like, so for instance, this is not in standard form. How could I take this, which I say is not in standard form, and put it into standard form? What do I need to do?
I'm sorry, I got interrupted. You said put it into standard
Yeah,
form?
so this is an ellipse, but it is not in standard form. What do I need? How do I modify this to turn it into standard form?
You take the square root of the bottom. So just
There we go. We take the square root and then we square it. And so now it's in standard form right there. So if I give you, which one is this? Oh yeah. So yeah, that's what I would be looking for right there. All right. So, all right. Finally, hyperbolas are almost exactly the same. The only difference is one of them's positive and the other one's negative. So I'm going to write that like this. I'm going to say, okay, x minus h squared over a squared. I'm going to go y minus k squared over b squared equals 1. And what I'm going to do is put a plus minus here and a minus plus here. This is pretty standard. You'll see this. This means that whenever this one's plus, this one has to be minus. Whenever this one's minus, this one has to be plus. Way different than if it were plus minus plus minus. That would mean they're either both positive or they're both negative. This means they have to have the opposite signs. And so there you go. And I mean, I'm not going to nitpick on this. If it ends up being that one's minus and that one's plus, it would be perfectly fine for you to do something like this. Right, that is perfectly fine. There's nothing special about the X going up front. That's just as long as it's like that. So, and it's usually nicer to see something like this as opposed to a plus and a minus out front. It just looks ugly. So any questions on the standard form? What I'm looking for standard form for each one of these guys?
Nope.
Okay. All right, moving on. So that was all for problem 3, where I say shown below is the graph of a conic section. And then I say find the formula for that conic section in standard form. I'm looking for one of those 4 guys right there. Okay. Problem 4 is exactly like problem 1. I say this defines a conic section. Identify the type. And so I want you to write either circle, ellipse, parabola, or hyperbola. Graph it, labeling the vertices, if applicable, the asymptotes, if applicable, and all axis intersections. Same thing as problem 1. Then finally, problems 5 and 6 are intersections of conics. And I want to briefly go over that. So I'm going to erase this stuff. And so this is exactly what your homework was. And we talked about this in class. If you have x, y equals, so I'm saying we want to find the intersections of two conic sections. And I give you something like this. And then, oh, I don't know, 2x squared plus 3y squared equals, let's do 6. Something like that. For these types of ones, I have recommended that the first thing we do is get this guy by himself. Graph it, and I'll read the prompt here because I want to be clear. It says, find the intersection of object and object by drawing a thumbnail sketch of the two objects, using algebraic methods if necessary, and labeling all points of intersection. And then I have in parentheses, you do not need to find the axis intersections. So that we're clear, that to be perfectly clear, that that's one of the few times in your life that I'm not going to ask for axis intersections. So I've recommended that for this type of setup where we have one of these types of hyperbolas, that's the first thing we do. We draw that guy and I say, okay, it's a positive, so it comes from high to low there and then goes down like that. And I've also recommended, hey, don't worry about numbers for this. We're going to do this highly qualitatively for these types of guys. And then, oh, well, now what am I going to do? I guess that is a, what is that?
An ellipse.
It's an ellipse. And I'm going to say, okay, well, I don't really want to skimp on this drawing. I would like this to be, I mean, we could just draw an ellipse. And I've recommended that when we have this type of situation, you do the worst case scenario where it hits at 4 places. But what I'm going to do, I'm going to go ahead and get this into standard form so that this thing is this, which reduces down to x squared over 3 plus y squared over 2 equals 1, which is not in standard form yet. Now it's in standard form. Root 3 squared plus y squared over root 2 squared equals 1. Now I'm going to say, okay, well, then the x has been stretched out to root 3. And then the y has been, so that's the bigger one. That's the smaller one. I'm going to go ahead and assume it looks like this, right? And I could be absolutely wrong about this. It might be the case that there aren't intersections. Maybe I drew this wrong. Maybe it only goes like this. Or maybe it actually hits here at 2 places. We don't know. This is kind of, so this is how I'm telling you to do it in the prompt of the question. Drawing a thumbnail sketch and using algebraic methods if necessary. Well, in this case, it's necessary. I don't know about you, but I can't just see, oh yeah, those are the intersections. I can't even tell which case we're at, like with this. So I'm going to have to use the big guns here for this one. And in this case, with this type of thing is we're just going to take this and substitute it in. And I'm not going to go through this because you had homework over this and we did it in class, but it would look something like this. 3 times y squared, y is 4 over x, 6. Notice I'm plugging this back into the original one. If I wanted to, I could plug this into this one. Everything would be the same. It's just, this is going to be a little harder to deal with if I tried to plug it into this one, but whatever. So we have 2x squared plus 3 times 4 squared is 16 over x squared equals 6, something like that. And then we move on from there, right? I see, oh, I got an x in the denominator, so I'm going to have to multiply everything through by x squared. and so on and so forth. And you've done a bunch of these now, you know what's a coming. And then from there, we say, okay, there are, if we do, I actually think, and this is my intuition, that this is going to be too small to actually hit it. I think that's been stretched up a bit too much. In fact, I'm certain of it. It's been stretched too much to actually hit that. At any rate, that's the deal, right? And I think you had one of those in your homework where you assume this and you do all this stuff and you get an imaginary number and you go, no, not happening, or something like that. So, okay. All right, so that's that type of thing. Now, what if, so any questions with this? Would you actually like to go through this, or do you feel comfortable with this thing right here?
I'm good.
Good. Okay. Cool. So that's the idea with these types, where you have a hyperbola that looks like this and one of these guys right here. Okay, so I'm going to leave that up and say, all right. Let's do it that way. We're going to say, okay, so now same prompt. Pretend that all this work does not exist, and you're given this prompt. It says find the intersection of this thing and this thing by drawing a thumbnail sketch of the two objects, using algebraic methods if necessary, and labeling all points of intersection. You do not need to find axis intersections. Okay, so I'm just going to follow instructions and say, do a thumbnail sketch. And so I look at this thing, and my first thing that goes through my head is, okay, wait a second. What type of thing is that?
An ellipse.
This is an ellipse?
Oh, no. It's a hyperbola.
Hyperbola. There we go, right? That's a hyperbola. And this thing is an ellipse, which we've seen before. And so we go ahead and we say, all right, well, hold on. I don't really know where these things live on the x-axis. It might be to my benefit to go ahead and find out what this thing looks like. So I take this thing, divide both sides by 6. I end up with this and end up with this. And so I'm going to draw. And in this case, since it's not one of those weird ones with the xy equals k with the weird hyperbolas, which we can't really get wrap our minds around, this is something that we actually can find some points and find out where they live. And so it might be to my benefit to actually do a good job, maybe or maybe not. So, and that's the thing with these by thumbnail sketch. It's like, it might be good to do a bunch of points. In the last case, it didn't help me at all because I had one of those stupid hyperbolas. But in this case, it might help me to do this. So that's what I'm going to do here. I'm going to say, okay, let's try this thing here. This thing goes through at plus and minus root 3. So really goes through the x-axis at plus and minus root 3. So what's really nice about this standard form, really nice about having the standard form is I've done all the work. I don't need to use my brain. I could just say it goes through x at plus or minus root 3. Goes through y at plus or minus root 2, which is a smaller number. So I'm going to go ahead and draw it a little bit smaller. Plus root 2 minus root 2. And so that's one of those guys right there. Okay. All right. So now this guy. Same kind of ball game, really. Like, I'm starting off with something like this, and it's not in standard form. I could wrap my brain around it better if I get it into standard form. So that's what I'm going to do. I want to take it, divide everybody through by 6. So that gives me y squared over 2, yep, minus, yeah, how about x squared? And why don't I write that as over 6/5? That should work, because now I'm just kind of double checking in my head. This is what's going through. If I write that as 6/5, I'll have x squared over 6/5, which is the same thing as x squared times 5/6. And that is x squared times 5/6. So yeah, okay, I feel good about that. I'm going to go ahead and write him as over 6/5, like that, equals 1. Not quite in standard form yet. I can't really see where these things are going to go through. So why don't I go ahead and do this? Square root of that thing squared, square root of that thing squared. Okay. That looks good. Okay. Now, here's the question. This is how I think of hyperbolas. I've already identified that's a hyperbola. So there's 2 possibilities for this thing. It either goes through like this, right? It's one of those that goes out, or it's one of those that goes up and down. Which type is this? The type that goes left and right, or the type that goes up and down?
Up and down, I think.
Up and down, yeah. And the way I think about it is, I say, well, the negative's on the x, which means that it can't go through the x-axis. You're not going to be able to solve for x for this guy. So he's got to be one of those up and down ones. Another way of thinking about that is, yeah, it does go through the y-axis, because when I plug in a 0 for x, it makes that disappear. And so I can solve for y squared. Okay, so it's an up and down one. What are the vertices here and here for that guy? See her in a minute.
Well, 0.
What now? Please don't do that, buddy. That's not nice.
Hug.
Would it be the square root of 2 and the minus square root of 2?
That is correct. Right, and hit that by plugging in a 0 for x, so that y squared over the square root of 2 squared is equal to 1, so that y squared is equal to the square root of 2 squared, so that when we take the square root, and this is why we have the standard form, so that we don't have to use our brain and take each one of these steps. Like we could then take the square root and we'll end up with a plus and minus square root 2, but I've already done all that work. It's all right there. I can tell by the way I've written this, and that's where it goes through. And so I have this type of thing going through at positive square root 2, going through at negative square root 2. So this thing looks like this. And now this is a thumbnail sketch. That means I don't need to worry about asymptotes and stuff like that. If I wanted to, I could find the asymptotes. And, they go like this. I could find formulas for them and stuff. But we don't need to do any of that. In fact, I think we're done with this problem. What are the intersections of these?
Square root of 2 minus square root of 2?
Yeah, but let's add that 0 into there. And so 0 minus square root of 2 right there. So those are my two intersections right there. 2 points of intersection, right? And so to go back to the way I've worded this, we say, find the intersection of this thing and that thing by drawing a thumbnail sketch of the two objects, using algebraic methods if necessary. Well, it wasn't necessary, was it? Like, we didn't need to take this and plug it into there and do a bunch of stuff like that. We could just see from here that those have to be the two points of intersection right there. And so we're done, right? The only thing then it says labeling all points of intersection. I mean, I guess technically I had done that by just having the plus root 2 and the minus root 2 there. But since this is like a question on a quiz, we want to be absolutely sure that, hey, there's no question Justin knows what I'm talking about here. That is that point of intersection right there. That is that point of intersection right there. And then we're done. We didn't have to do any algebraic methods whatsoever. And so that's what the quiz is going to be over. I would definitely want to, if I were you, I would definitely be sure that I know how to graph all this stuff, right? Like if I gave you it's going to be really important. Shows up at least 4 times is completing the square. And if you could, given one of those general ones that we talked about at the beginning, you know, like the 2x squared plus 3y squared minus 4x plus 12y. And we did plus 20, but when we did plus 10, it actually worked out to an actual thing. Right? It worked out to 2x minus 1 squared plus 3y plus, what was it? That came out as a 4, so a 2. It worked out to that you could start with something like this and be able to actually graph this thing, which would work out like this. Yeah. So that you feel, it would be good if you feel comfortable going from this to this and actually being able to graph that, right? And doing that in reverse. Given a graph, can you come up with this thing right here? Not so much going all the way back to this thing. I mean, we could if we were so inclined, but that we could take a graph, right? So like if I said, well, you have plenty of examples in the homework of that thing, of doing that, where you're given a graph and you put it back in the standard form. That's going to be good. I would just review doing that with circles, ellipses, hyperbolas. I'll level with you. You're not going to see many parabolas on this quiz. I'll just go ahead and throw that out there. Probably don't need to worry too much about parabolas, but you might want to know whether or not this thing's a parabola. That might, maybe I'm showing my hand a bit too much there, but you might want to be able to tell if an equation like this is or is not a parabola. We talked about that just a few minutes ago. And so that should be about it. Any last questions before we finish for today?
I don't think so.
Cool.